let's get started with some problem solving for today. My name is Praveen and I discuss 12th standard CBSE physics. As a reminder, it is recommended that you click on the notes in the description and follow along with my narration, with my explanation. That is the best way to do it, so that you are having access to the very same material which I show on this video. We are going to solve some questions on electric potential again. This is our 10th question. We have a square like this. This is a square, and this square has a side of √2 meters. It isn't meters, √2 meters. And we have charges on all four corners of the square, and they are like this: 100 microcoulomb, minus 50 microcoulomb, 20 microcoulomb, and then minus 60 microcoulomb. Now let's say we are joining the diagonals of the square like this. The question is, what will be the electric potential at this center? Now to do that, can we first calculate how long the diagonal will be? The diagonal we are looking at, let's say this, is given by the square root of sum of the squares of the other sides, which is by the Pythagoras theorem. So we do this as √2 squares, √2 squared plus √2 squared. Speaking about square root of 4, that is 2 meter. That is the diagonal. Then if that is the diagonal, then we could split that into 1 meter, 1 meter. So the charges are at a distance of 1 meter from the center. Now let us calculate the potential at the center. So potential is given by V equals 1 by 4 pi epsilon naught, given by Q by R, but we have 4 Q's here and 4 R's here. So let's do that because we are dealing with 4 different charges. So Q1 by R, the distance is still the same though, Q2 by R plus Q3 by R plus Q4 by R. 1 by 4 by epsilon naught is 9 into 10 to the power 9. Let me take the R out. So it will be 1 by 1 multiplied by Q1. Q1, let me take it as 100 minus 50 plus 20 minus 60, and all these are in microcoulomb. So as a result, I multiplied by 10 to the power minus 6. 9 into 10 to the power 9 into 10 into 10 to the power minus 6, or 9 into 10 to the power 4 volts. That is the final answer. Let's discuss question number 11. We have a square again. This is a square. Let's call this square as A, B, C, D. And the side of the square, each side of the square is given by A. Now I'm placing some charges at the corners of this square like this: plus Q, I'm keeping plus Q again, minus Q, minus q. So let's highlight our charges. These are our charges at the four corners of the square. And this is the order in which they are kept. Now, let's say I'm joining the diagonals. I am interested in finding the electric potential at the center. Electric potential at the center. That is the first thing we have to find out. And then I'm also making another assumption. Let's see, this is E, this is E, and this is F. These are the midpoints. They are the midpoints of the sides BC and CD respectively. So I'm taking a charge from O to O to E and F. So let's say I'm moving a charge of E. What is the work done? In moving E from O to F and O to E. Let us do our computation here. Firstly, OA, OB, OC, OD. We could take them all as R. Right? So what I'm saying, this, they are R. Now let's calculate the potential at the center. Oh, it is given by 1 by 4 pi epsilon naught into Q by R plus Q by R from B, then minus Q by R from C, and minus Q by R from D. Right? This is from A, B, C, D. If you look at it closely, it is equal to 0. Now, let's look at the potential at E. Now, if you see the potential at E, that is 1 by 4 pi epsilon naught. Let's go back to E. I am looking at it here. So, at E, the potential is given by 1 by 4 pi epsilon naught into Q by B. This is the charge that comes from B, minus Q by CE. This is the charge that comes from C, minus Q by DE. This is the charge that comes from D, plus Q by AE. This is the charge that comes from A. Okay, so let's remember this, where these charges are coming from. They are all going to get cancelled out, okay, because BE and CE, they are the same. So you could see that BE, CE, they are the same. Then DE if I join and AE if I join, they would be the same. So this is going to be again 0. Let's look at the potential at F. Going to be 1 by 4 pi epsilon naught into, similarly we can calculate minus Q. So if I'm calculating it from DF, this is from D, then minus Q by CF. Okay, so this is from C. Then Q by AF, this is from A, plus Q by BF, this is from B. If you go forward, now let's look at AF. So what is AF? Let's try finding AF. Okay, so this is AF. Now if I want to calculate AF is equals square root of, this is the hypotenuse here, so I have to do AD square plus DF square. So AD square plus DF square. AD is A and DF is A by 2. Square root of A square plus A square by 4, which is equal to square root of 5A square by 4, or root 5A by 2. Alright, so if we proceed further, 1 by 4 by epsilon naught, then I could take this as minus 2Q by DF, because DF and CF are equal, plus 2Q by AF. Now let me take 2Q out. It becomes 4 pi epsilon naught minus 1 by DF. So DF is, this is A by 2, not A. DF is A by 2, then that will be 2 by A, plus AF is root 5A by 2. So substitute this, we will get 2 by root 5A equals, so if we take the other 2 also out, so it will cancel with a 4 here, so it becomes Q by pi epsilon naught. You could also take A out into A into 1 by root 5 minus 1. This is the potential at F. Now work done to move the charge from 0 to E is given by the charge into the potential at E minus potential at O equals E into 0 minus 0, because E and O both have 0 potential, it is 0. Similarly, if we do work done for O to F, that is equals charge multiplied by potential at F minus potential at O equals E into Q by pi epsilon naught into A multiplied by 1 by root 5 minus 1. I could write it as QE by pi epsilon naught A into 1 by root 5 minus 1. That is the answer to our question.